Just like the street lights lit this town, like a fire in a blaze, gotta burn it down. Can't be afraid to leave this out. We got this far, don't know how. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we're gonna let it rain. Tonight, we're gonna let it rain. Tonight, we're gonna let it rain. Just like the sunrise, we're gonna let it rain. Just like a spark that's breaking out. Can't make a stop, can't turn back now. We know that there's no room for doubt. No, we can't turn back now. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we're gonna let it rain. Tonight, we're gonna let it rain. Tonight, we're gonna let it rain. Just like the sunrise, we're gonna let it rain.
Ember. Oh, Ember.
Miss Ember.
Oh, great, Ember. Tell me what I'm doing.
Appreciate you, Ember.
Love Ember. She's great.
Bottom of the barrel Ember bullshit.
Oh my God, Ember.
Ember. Ember.
Ember.
We love you, Ember.
You rock at that, Ember.
Ember is the queen.
We're neighbors, Ember.
I see you, Ember.
Hey, Ember is hot.
Hello, everyone. Can you hear me way up there? It's day 700. 100 weeks since I got my legal name change. Because I've been doing this for a while and different things start at different places. So it seems like when I got the legal paperwork back, that seemed like the place to put a pin in the calendar, I suppose, for lack of a better term. So yeah, 100 weeks. I'm doing a special about it tonight. I hope you'll join. But for today, hold on. There's a thing. Lil sends a super chat for $2. Thank you, Lil. And says, space! We are indeed doing space. But first, Lil also sent us 5 gift emberships. Thank you, Lil. Those went to Kiwi Banana, Pinworm, Fella's Ghost, possibly. Forgive me if I mess these up. My monitor is very tiny and the words are very small. I need magnifiers, really. But c'est la vie. I can't read that one at all. Lortigan Nightshade. Hopefully it's close. And I am sorry, folks. I cannot read these damn things to save my life because I have a very tiny monitor. Parasaurolophus. Holy shit. Parasaurolophus. Thank you, Lil, and everybody. Do enjoy all the fun custom emojis, exclusive members only content, and all the other goodies that come with membership. I hope you decide to stick around because it helps a lot. And Lil, I very, very much appreciate it. All right. Now let me see here. I realize the view is a little bit different. I'm gonna have to work. I'm probably gonna adjust. Because I want to be able to look at y'all, but also look at the screen, but also not be so damn close all the time so that you like can see more than to hear. Like when I have an outfit on, like today, because it's day 700. I'm such a ridiculous person, folks. If the weather stays clear-ish, I have to go to the store after the show. So I'm going to have to change into normal clothes. Well, snow clothes, go to the store, come back and change back for tonight's show because I am a silly bean. But at least I have pockets. So there's that. And it feels so smooth. I love it so much. Even though I'm feeling blue, weirdly. I'm blue, but I'm also, I don't know. We have mixed, complicated emotions around here. But today, space. We're going to space. Now, first, let me change my background back because we need space if we're going to be in space. And then, now I want to start locally because there's a lot of space. We're not going to get to all of it today, but I do want, you know what, we can do this. Yeah, we can do this. This isn't bad. My name is blocked out by my layout, but that doesn't matter. Y'all know my name. It's right over there in the corner. It's whatever. Anyway, I want to start with the new pride flag. The hold please. It's in a different section. This beastie, which to celebrate the anniversary of the incoming current presidential administration, I recreated NASA's pride flag. So quick rundown for anybody who isn't familiar. In 2024, Rachel Lenz, a researcher with NASA, created a pride flag out of NASA images and for Pride Month 2024. And it was really cool. In January of 2025, the incoming presidential administration erased it from NASA's servers. So to spite the tiny tyrant, this year, I recreated the pride flag by tracking down the constituent images and then adding new ones to bring it up to the current level of the more inclusive pride flag. So I want to start by going through the bits of the pride flag. And incidentally, if you want a copy of this side, the image is double mirrored and it's hard to keep track of sometimes. I don't know why it's double mirrored instead. Whatever. It's not important. Anyway, betterthanember.com. If you want a print, we've got it in the store. If you want an actual flag, I figured that out. It's in the store. It's a little bit more expensive than pride flags you might be familiar with. There's a couple of reasons. One is the level of detail. It's not just colors. There's stuff going on in each of the layers, but that's up to you. If you just want the image, because it's made entirely from NASA photos, theoretically, the derivative work is also, I could make a case for there being things, but TLDR, the image, the high resolution version is also on the website. So you can get a print, you can get a flag, or you can just get the image if you want it for your phone lock screen or whatever, right? It's all there on the website for your use. But because we made a big old splash by rebuilding and upgrading the Space Pride flag, I want to start with that. So, oh shit, I switched screens again. I'm bad at my job. So we'll start with the original Pride flag and work our way up. And with original flavor Pride flags, the red is on top. So we'll start with the red. Now, this is gonna be tricky because I kind of want to keep referencing the pride flag, we'll start with the red. You see, it's got like spiky looking things. Now, I couldn't find the same exact image as on that one. So I tracked down, it's red sprites. It's red jellyfish sprites. That's actually an Earth phenomena. It starts here on Earth. But NASA deals with atmosphere stuff as well as space stuff. So there's a bit of that going around too. And it's pretty neat. So let me see if I can make this a little bigger. I mean, I could just do, I don't know if that's super useful. What other tools have I got? We could do that. Nope. How about, well, it's bigger. It is technically bigger. I don't know if that's more useful, but it is bigger. Giggity. All right. Anyhow, we'll start with the red sprites. And why? Just as I'm switching screens, an ad pops up. All right. The mysterious red sprite lightning strikes over the Himalayas. Now, this is not the same red sprites, but it's the same phenomenon, you see. So this is from the Chinese Academy of Sciences. Have you ever heard of or seen red lightning? It's a special flavor of lightning, folks. It actually is. It's not exactly lightning. It's a similar phenomena. I'm sure we'll get into the details of the thing, but it's much, much, much dimmer. Like regular lightning will blind your camera. If you calibrate for the lightning, you can't see anything else. Whereas this stuff, these red sprites, they're so dim you can see the stars behind them. So much, much, much lower light level. These are not animated characters, but a real atmospheric phenomena known as electrical discharges that occur high above thunderstorms. Scientists refer to them as red sprites, named for their jellyfish-like appearance and vivid red flashes. Now imagine witnessing these mesmerizing displays over the world's highest mountain range, the Himalayas. And we can see in the image that these are very high mountains that are already poking up into, well, not the stratosphere exactly, but pretty high up. And they're getting close to the bottom of the sprites. It's interesting. It's interesting to me anyway. On the night of May 19th, 2022, two Chinese astrophotographers, Angel An and Su Changdong, captured a spectacular display of over 100 red sprites over the Himalayas. Now, there's a lot to say about the phenomenon, but there's a lot of phenomenon to cover today. So we shall summarize. These are secondary jets. The first ever recorded in Asia, I guess, with green air glow. At the base of the nighttime ionosphere. So ghost sprites. The extraordinary event attracted global attention and was widely covered by major media outlets. Now, if you Google red jellyfish sprites, you will get a lot of results. It's not exactly a rare phenomenon, but it is rare to get it that close to ground level because the ground level is so high in the air, if you follow. And also, I'm sure there's a perspective thing going on, but that's not super important. But if you Google it, you can find a lot of examples. Be careful, though. It's one of the more popular things that people make AI fakes out of, to make them look more like jellyfish or more like spaceships or whatever. So there's a lot of fakes. Make sure you're getting your images from a reputable source, like, the European Space Observatory or, something scientific, and not just Twitter.com, for example, where there's a whole lot of AI nonsense going on these days, but whatever. The rest of the article seems to go on about witnessing the sprites, but there is a study here. I don't know if they mention the study. Maybe I'm missing it by skimming, but in any case, we're trying to figure out what causes them precisely. They seem to coincide with thunderstorms. They form high above the thunderstorms. And it seems to be that when there's a larger number of lightning strikes, there's a larger number of sprites, but they aren't directly physically connected that we can see. It's almost like the lightning isn't grounding the cloud, but something else in the ionosphere that gets either drawn in or discharged. It's hard to say which way it's going. And then there's a field, a layer of perhaps Earth's magnetic field, we're not entirely sure yet, where the energy persists in a kind of invisible form, like it's precipitating, and then it's like vapor, like clouds, right? Like cloud water vapor is there, but it's only visible when you drop below the dew point, and then it forms a cloud or a fog or what have you. But the same amount of water vapor is always there. It's just not visible unless atmospheric conditions cross a certain threshold. But it's the same energy. The clouds that you see aren't all the cloud there is. The bottom edge of the cloud, that's just the dew point line. There's more cloud that's just not visible because it's on the other side of the dew point line. Similar thing seems to be the case with the electrical impulses involved in lightning. There's something going on high above. There's an area where it's not visible due to atmospheric conditions, and then there's regular lightning down below. And which causes what, we're still trying to track down, and that's pretty neat. But TLDR, that's the red stripe on the flag. Next, we have the orange stripe, and the orange comes from Mars. It's literally the Intrepid crater on Mars, and that takes us right into space, and I love it so much. Mars, as you may be aware, is a very, very, very dry place. So before we go to Mars, we should take a moment to hydrate. Hey folks, I've been working hard on my health, and so far I've lost over 140 pounds. A huge part of good health is hydration. That's why I'm thrilled to partner with Epic Water Filters. Check this out. Not only can you say goodbye to expensive bottled water, but these filters are made in the US, so no tariffs, and they're made to fit your life. From these lovely pitchers I can fill from, to sink units, to portable filters that fit in your reusable bottle. With Epic, I can refill from nature's water sources and not have to worry about bacteria and whatnot. But also, send back a used filter to be responsibly recycled, and they'll send you a free replacement, saving you and the Earth even more. Want to save a ton of money, be healthier, and build a better world? Head to epicwaterfilters.com and enter code EMBER15 at checkout for 15% off. Don't settle for random water. Upgrade to Epic. All right. I was trying to catch up on the chats in between, and I saw Deviant said something in Swedish, and I was trying to grab the text so I could try and translate it, and it didn't work. I can't do that on this screen. It's fine. It's fine. Oh my. So yeah, I was trying to. I just can't keep up. I can't keep up with y'all. Deviant said something about a blankie. That's a possibility. Figuring out how to do the flag took a bit. Because, like I mentioned, it's not just colors, right? It's stuff on each thing. It's big. It took a minute. It hadn't occurred to me to put it on a blankie or something. Maybe I'll look into that. I don't know, but I've such mixed thoughts about it. So yeah. That's right, Fern. Don't just wet your thirst. Get especially wet. Get entirely wet. The most wet. These if you are a dirty slut for water, be a responsible hydro hoe and use protection. epicwaterfilters.com, code EMBER15. All right, Mars. Welcome to Mars. Oh goodness. I wish we could see more of my space background with this setup, but it makes the thing more visible. So it's all good. It's fine. We will persevere, which is a whole different space mission. Never mind that. So the Intrepid crater on Mars carries the name of the lunar module of the NASA's Apollo 12 mission, which landed on the moon November 19th, 1969. NASA's Mars exploration rover Opportunity recorded this view of the crater during the 2,417th Martian day, or SOL, of the rover's work on Mars, November 11th, 2010. So you see, they named the crater because it was close to the anniversary of the landing on the moon. these rovers don't move very fast. They're not driven by humans. They just kind of robotically roll along based on their solar power and so forth. And so it took it a while. I forget exactly how long it took it to cross the crater, but it wasn't going to find anything else interesting before the anniversary showed up. So they named it in honor of that anniversary. The view is presented in approximately true color, combining exposures taken by Opportunity's panoramic cam, the PanCam, through 3 filters emitting wavelengths of 601 nanometers, 535 nanometers, and 482 nanometers. That roughly equates to red, green, and blue, give or take. So we've got 3 colors, but it's the same 3 colors our monitors use, and so we can get close to true color. The Intrepid crater is about 20 meters in diameter, which is about the same size as the crater where Opportunity spent its first 2 months on Mars, the Eagle crater. The rover's look-back image into Eagle crater after driving out of it in 2004 is linked here. It's photojournal.jpl.nasa.gov/catalog/PIA05755 for anybody who wants to actually type that in. But details. The rover science team uses a convention of assigning names of historic ships of exploration as the informal names for craters seen by Opportunity. Now, this is an interesting thing that NASA does a lot when they're naming shit, is they will pick a weird, nerdy tradition and then just use that for the whole thing. For example, the craters on Mercury are named for artists and philosophers. The moons of Uranus are named for Shakespeare's women, except for Oberon, because of Midsummer Night's Dream. But never mind. The Pluto system seems to have a thing for gods and goddesses of night and death and darkness and whatnot. Although not always, because we've started to just give them numbers like P4, for example. C'est la vie. But and of course the planets themselves tend to have names from the Greco-Roman pantheon. So yeah, we like our nerdy little traditions. And it certainly beats the old areological tradition of just assigning them letters based on grid systems. Like one of the old Martian grid systems was a y-axis of A through Z and an x-axis of A through Z. And so the crater would get a designation based on where it lined up on that grid. So you'd have crater ZP, for example. And if there's more than one crater in that grid sector, then it would ZP1, ZP2, ZP3. And it was weird and arbitrary and no one liked it. But you could find things on a map if you had the right grid aligned with the right map. So there's that. We really need like a proper coordinate system for Mars, but the trick is where to put a prime meridian, since there isn't really a big clock we can have the line run right through arbitrarily. Details, though. So the rover science team uses that convention of naming things after historic exploration, and the Intrepid carried astronauts Alan Bean and Pete Conrad to the surface of the moon, while crewmate Dick Gordon orbited overhead in the mission's command service module, Yankee Clipper, which is Americans should not be allowed to name things. No. And then they have links to that whole thing, and then there's a download for the image itself. So hooray! And that is our orange color, which, Mars, very orange, makes sense, absolutely. So next we're going to move on to yellow. And that brings us to Io, or Io, depending on how you want to pronounce it. One of Jupiter's planet-sized moons, a little bit further out into space, which is pretty neat. Now, this is the map that was used for the layer of the flag. It's the whole surface of Io. The edges are stretched a little bit because that's what happens when you convert a 3D globe into a 2D surface. It's almost like a Mercator projection, but because Io is much, much smaller, the geometrical distortion is much more intense. Details. But for example, the craters if you imagine like the scale of the Earth, that crater takes up a percentage of the Earth roughly equivalent to North America. That's a big crater, but Io is much, much smaller. And so the crater isn't actually that big. It's a thing. It's a whole thing. Io is one of the more remarkable moons, not just for being one of the Galilean satellites of Jupiter, so named because their discovery by Galileo in the roundabout 1600-ish is what showed that not everything goes around the Earth, and therefore the geocentric model being put forth by the church was wrong, and therefore the church was wrong, and therefore science could find things that didn't agree with the church, because the church was demonstrably not infallible. And so when we start, it made it possible to think things that went against the church's teachings, which is a neat trick, but also runs a pretty high risk of getting you burned at the stake. But we don't talk about Bruno. So it's also interesting for a number of other reasons. It was one of the first that Galileo spotted because it's so fucking big, but also because it's geologically active. It's so close to Jupiter that it is either tidally locked or like our moon, or is on the way to being tidally locked, but it's still geologically active. Well, why? Well, there's a couple reasons. The first is it's so close to Jupiter, it's experiencing extreme tidal forces. Jupiter's gravity is pulling much harder on one side of the moon than the other, and that's screwing up how things work inside. Another is Jupiter's stupid intense radiation field. It doesn't just have a magnetic field, it has a radiosphere. It's very hot. It's very hot. And Io is getting, to put it another way, we can't land a probe on the surface of Io without sending it in a Faraday cage, because it would get fried by the radiation. But if we sent a probe in a Faraday cage, it couldn't transmit back to us. So we can't actually do the probe thing yet. We're working on it. We don't know if a probe would last very long on the surface of Io either, because again, it's geologically active. There's volcanic eruptions. It's kind of known for that, for being a volcanically active moon. It's one of only 2 moons that we know have regular volcanic activity, and the other one is a cryovolcano that erupts ice instead of magma. But I mean, water is just rocks at a different temperature. Geologists, it's a thing I say to annoy the geologists, because we have this human-centric view of things, because water exists as a liquid in our base state of comfort. We kind of have this humanocentric view that that's how water ought to be, that it takes extreme cold to make it hard, but extreme cold is a relative thing. Elsewhere in the solar system, extreme cold is just the normal temperature. And so water is just another crystalline mineral, much like, granite or basalt. It's a rock. It just happens to be liquid at our temperature of comfort. That's somewhat misleading, though, because the other rock structures are much more molecularly dynamic. There's a lot more going on than just 2 hydrogens and an oxygen, but it's fun to tease the geologists with. I digress. So this is a very short one. NASA doesn't have a lot to say on this. The base map of Jupiter's moon Io was produced by combining the best images from both Voyager 1 and Galileo missions. The movie, I don't know what movie we're talking about, but the movie shows 2 sped up. NASA, I realize English is not your subject, but it's sped up. 2 sped up rotations of Io. A single rotation takes 1.77 days and begins with a view of the Jupiter-facing hemisphere. So yay, that's pretty neat. 1 minute read. They weren't lying. So yeah, you can, because they have a full scan, you can find it in various 3D reconstructions where either it's modeled so that it spins as a view, or in VR, which is really neat. Theoretically, you could have a VR where you're floating in space, and you could actually go all the way around Io and see it in VR, which is it's really neat when you can pull off that kind of thing. Somebody may have to build one of those. I digress. Oh, Hellbound Hillbilly says IO is really great, but I love Ganymede. You know, Ganymede is a popular one. There's I forget exactly who the author was, but it's called the Daedalus Incident. And it's about humans on Mars build a big old particle collider, but it accidentally starts to like contact the next universe over because they also built a particle collider on the same spot. And so the particle colliders are like interfering with each other and they're kind of tearing holes in reality sort of deal. It's an interesting story. In this next reality over, it's like the 1700s, and Ben Franklin leads the United States of Ganymede in their war for independence against the Terrans, which are led by Britain for some reason. It's a whole thing. It's a very interesting story, though. It's pretty fun. Oh, in any case, Ganymede, very popular choice. But of course, that's Ben Franklin as an alchemist leading the United States of Ganymede. It's a whole thing. In any case, next thing is, let's see, green. So for green, we're going to go back to Earth. And that brings us to Clear Lake, which is, it turns out, not actually clear. This is a lake in California that suffers from algal blooms. Outbreaks, I suppose, of algae, which we normally consider to be okay or just fine. In fact, there's a series of state parks nearby where I live called Green Lakes because they have algae and such. But algae isn't always super healthy. It isn't always enriching us with the oxygens and the things. So, you know, we got to be careful with that. So an algal bloom in the waters of California's Clear Lake in mid-May 2024. Bright green. Talking all the time is hard, folks. I invite co-hosts, but they can't always make it. We're doing our best. Bright green swirls were visible across most of the lake's area when the operational Land Imager 2 on Landsat 9 acquired this natural color image on May 15th. The bloom may contain blue-green algae, also known as cyanobacteria, as well as other types of phytoplankton. Only a direct sample can determine the exact composition of a given bloom, but cyanobacteria are single-celled organisms that rely on photosynthesis to turn sunlight into food, and some produce microcystin, a potent toxin that can irritate the skin and liver and cause kidney damage. And that's a bit of an issue because it isn't always immediate. Sometimes you build it up over time. Sometimes a single exposure can give you a harmful dose, but it takes a while to set into your system. And tracing it back to an algal bloom isn't always easy. It's also less easy to reverse. Clear Lake is naturally nutrient rich, a eutrophic lake that supports the growth of algae and aquatic plants, located about 60 miles, 100 kilometers north of San Francisco Bay. Oh, I should do my announcer voice. Located about 60 miles or 100 kilometers north of San Francisco Bay, it has long contained large algal populations, possibly since the end of the last ice age, about 10,000 years ago, according to sediment cores. In recent years, however, people have increased nutrient inputs into the lake, and the number of harmful blooms has increased. Out of more than 130 algal species that have been identified in Clear Lake, 3 species of blue-green algae can cause adverse human health effects under certain conditions. Blooms of these harmful algae tend to occur in spring and late summer, according to Lake County officials. Oh, goodness. That's a fun voice to do, and I really should practice because it helps me get the tone and the resonance in the right places. I've been shit at voice training for like the past year. One does one's best, but details. I can do it, though. I'm just priorities in other places. But my heater's running again, so I have to give you guys a break because I'm going to melt. And a puddle ember, I'm already blue. I don't need to be a puddle. So we'll just put on a quick break. I think for this one, since I only need a second, we will do, well, I mean, we could we could do this one, but it's literally only 3 seconds.
Are you about to engage in blasphemy?
I find it very fun. You know what? We'll do. Nah, I want to do a fun one. So, not for nothing. You don't have to believe science about algal blooms. You could also just believe some random conspiracy, I suppose.
Are you feeling the world is leaving you behind? Do you look at all the pseudoscience, rumors, and wild speculation on the internet and wonder, why can't I do that? Well, friend, you can. We can help you. We are Conspirowin. Conspirowin has a long history of helping anyone with a hidden truth. We will get your message out. The conspiracy theories you see today all started out with one person's vision. The moon landing hoax was launched by a NASA engineer whose manager didn't okay his vacation request. Conspirowin was there to help out. Christianity started out because one little girl named Mary got pregnant out of wedlock, and Conspirowin saved the day. Now, the virgin birth is accepted Catholic doctrine. You may be thinking, but my idea of the center of the earth being made of ice is far-fetched. No one's going to believe that. In a world where people believe windmills cause cancer, we say no dream is too big. Conspirowin will take your fledgling idea and feed it to our YouTube, Twitter, and TikTok operatives. And these savvy social media professionals will raise doubts with the prevailing scientific consensus. They will say, no one has ever seen the planet's core except Jesus. And science is wrong all the time. That's why science has theories and not Jesus. Within 30 days, we guarantee you CNN will run a story on how your conspiracy theory isn't true. We will also give you 100% assurance Fox News will say your crazy idea about the Earth's core being an icy ball is true. Follow your heart. Listen to the voices no one else can hear. Team up with Conspirowin.
Now, as I was saying earlier, ice is under so you might consider it to be a rock. So it could be that the center of the earth is made of ice. Possibly it's liquid ice. But there's some fun things about ice. Liquid water, as I've said many times, depends on both temperature and pressure. It doesn't matter how high the temperature is if the pressure is high enough to force it into solid form. So, it's not impossible that the center of the earth might be made of ice. It's very, very, very unlikely, however, especially because we have data that shows us some information about the nature of the center of the earth, right? We've analyzed seismological readings like P waves and S waves from geological events, earthquakes, and so forth. And the data tells us that the center of the earth is liquid and therefore it can't be ice because ice is a solid. But details, just because we can rule out a hypothesis doesn't mean it isn't still a fun idea. But as My Unfinished Journey says, ice are dumb as rocks. So yeah, that's a valid point. And it's a real shame that here in the United States we're having such a big ice storm. And I understand why people want to do salt about it. Just saying for no particular reason. Sapphire says the center of the earth is cheese, like the moon, because they're made of the same material. Yeah. All right, let's continue along because, despite all the things, we do only have so much day and there's a lot of flag to cover. So I reckon we should move on to Neptune, which is the blue stripe. That's right. We are actually making progress. We are all the way over here now. So yeah. Okay, Neptune, everybody knows Neptune. It's the 8th planet. It's also very blue. In fact, the section of the flag that's blue is from this photo of Neptune because it's very, very blue. So let's do a little quick rundown on the Neptunes for the purpose of completeness, because I don't want to just leave it out and be like, everybody already knows what Neptune is. So yeah, well, let's do history. History's good. It's possible Galileo may have seen Neptune. Possible. Not super likely. His telescope was good, but not that good. Some of the earliest known telescopic observations ever. Galileo's drawings on 28 December 1612 and 27 of January 1613 contain plotted points that match what is now known to have been the positions of Neptune on those dates. Both times Galileo seems to have mistaken Neptune for a fixed star when it appeared close in conjunction to Jupiter in the night sky. Hence, he is not credited with Neptune's discovery. At his first observation in December 1612, Neptune was almost stationary in the sky because it had just turned retrograde that day. This apparent backward motion is created when the Earth's orbit takes it past an outer planet, but because Neptune was only beginning its yearly retrograde cycle, the motion of the planet was far too slight to be detected with Galileo's small telescope. In 2009, a study suggested that Galileo was at least aware that the star he had observed had moved relative to the fixed stars. And there's a citation, which is why we're talking about this at all, right? Like, observing something, it's not identifying that it is a planet, it's controversial. But if he made notes saying this thing has moved, I don't know it to be a planet, though. Remember, for Galileo, the fact that there were moons orbiting Jupiter was brain-breaking. He was so set in the world he'd grown up in, where the church is right about everything all the time. And the church had told him his whole life that the planets only go out to Saturn or maybe Uranus. I forget where the church put the boundary, but for the idea of there being a planet beyond that point, it was inconceivable to him, you know? Just having something that doesn't go around the Earth broke his brain a little bit. It's pretty wild. Also, worth noting about Galileo, despite what your grandmother may have told you, there's only one person who has ever stared at the sun and gone blind, Galileo. And he did it through a telescope. And we're not sure it wasn't just normal macular degeneration. So that seems to be a myth. Not that I'm saying you should stare at the sun. That can be very painful. And it'll definitely blind you temporarily. It could still cause damage. I'm not saying it's safe. I'm just saying that what Grandma says about staring in the sun making you blind seems to be a myth. Just to be clear. In 1821, Alexis Bouvard published astronomical tables of the orbit of Uranus. Subsequent observations revealed substantial deviations from the tables, leading Bouvard to hypothesize that an unknown body was perturbing the orbit through gravitational interaction. In 1843, John Couch Adams began to work on the orbit of Uranus using the data he had. He requested extra data from Sir George Airy, the Astronomer Royal, who supplied it in February 1844. Adams continued to work on it for a couple of years and produced several estimates for the position of an undiscovered planet beyond Uranus. Because what could possibly be out there beyond Uranus? But it's an interesting story. As you may be aware, Neptune was discovered mathematically, and then once we figured out where it should be, we looked with our telescopes and there it was. We've come a really long way with our telescope ability, because nowadays we're finding lots of stuff. Asteroids that are only 100 meters across, for example, zooming through space by detecting anomalies in our telescope view fields, and then calculating out their orbits, and then eventually sussing out their size and so forth. Like, we're seeing the anomalies first and then figuring out what they are from the data we collect, as opposed to collecting the data and then predicting where they'll be, which is a very neat trick, but we see a lot more of the sky than we used to. Like we had to look for things specifically. Now we tend to look and we see things generally. And it's pretty neat. In any case, oh goodness, I have so many windows open and I'm inconceivable. Oh, heavens to Betsy and things. Oh, we don't have a very good view to look at right now. I don't know. It's we're doing our best here. Let me move my light a little. At least I'll be slightly shinier. Ah. All right. Let's see. I had a general idea of how long I want to spend on each stripe, but I forget exactly where I'm supposed to be in terms of things. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 colors. And we're just now finishing blue, which is 5. So I need to pick up the pace a little bit. So we're at, you know what? We've got a couple of minutes before I have to do my midway break. I mean, I don't have to do a midway break. It's just sort of a tradition at this point. People tune in expecting it. But we did start a couple minutes early, so I've got a few more minutes. Let's see if we can finish the original pride flag, red to purple, and then we'll go on to the progress pride flag stripes in the second half of the show. So next stripe is this guy, which is the Crab Nebula. This is, now you may be familiar with a different view of the Crab Nebula, perhaps this view, but that view was a specific wavelength from the Chandra X-ray Observatory, colorized into a spectrum that humans can see. Purple is on the higher frequency end of the spectrum, so they went with purple for that one. The Crab Nebula is really, really fucking cool. And so this is like different wavelengths combined to make this it's a composite of multiple wavelengths, which is why it looks a little more detailed than, like, say, the Hubble image you may have seen floating around, which is also very cool. But Hubble is visible light, whereas this is radio, infrared, optical, ultraviolet, and X-ray all combined, which is fucking neat. And it reveals a lot of detail. For instance, this internal structure. Oh, damn it. Why won't you do as I say? Right? Like, we see the nebula and it's really cool, but we can also see in the very center, there's this swirl thing. It's hard to tell from the angle we're seeing it at whether they're concentric rings, like ripples in a pond, distortions within the matter, or if it's an indrawing spiral like we see at the center of galaxies, whirlpools, and so forth. In other words, is this the supernova's echo, like the rest of the nebula, or is it a singularity at the center of the supernova that's starting to draw things back in? It's fascinating to figure out which, or to consider which. But I digress. What is the Crab Nebula? This talks about the detail of the image. The Crab Nebula itself was the result of a supernova observed by Chinese astronomers and other astronomers. But we know it was the year 1054 because of the Chinese astronomers who wrote the shit down. Like, all their astronomers noted the thing, but most of Europe was using regnal years at the time. So everybody wrote down, it was year 18 of the reign of King Bob, or some shit like that. And so it was very hard to figure out which year lined up with what. Whereas the Chinese just went, it's this year. There it is. And yeah, it's nice to have a culture that has a calendar that just runs across all of history, at least sometimes. But that's another story for another time. Mine Finished Sock says, don't get crabs from the Crab Nebula. Like and share the stream instead. Now, the supernova of 1054, I wish there were more about it, but Crab Nebula is a supernova remnant. Let me pull up real quick. Crab Nebula supernova. Okay, maybe. Oh, you know what? Let's do the NASA page. There's a NASA page about it. Messier Object 1 the first entry in the Messier catalog. Better known as the Crab Nebula, Charles Messier originally mistook Messier 1 for Halley's Comet, which inspired him to create his famous catalog of objects. He was like, oopsie, maybe we astronomers should start writing this shit down. So it's 6,500 light years away. Light years away. Apparent magnitude 8.4, which is really bright even now. This explosion that took place 1,000 years ago is not that far off from naked eye visible, TBH. Like, you can see it with decent binoculars. Now, it's spread out, so it's a lot easier for a camera to see it because a camera can just sit there and gather light. But yeah, you can find it in the constellation Taurus. It is a supernova remnant. Here's a more popular picture, although much bigger than I'm used to seeing. This is very cool. You can see some of the structure of the gas and whatnot inside it. So in 1054, Chinese astronomers took notice of a guest star, a guest star. Ages before television, we had guest stars that was for nearly a month visible in the daytime sky. A daytime star, not just like Venus that became visible before the sun was really completely fully set, but like a star visible during the day, and at night, stupid bright. Supernovas, 6,500 light years away. And the explosion was so bright we could see it during the day. Wild. So it was a supernova, which eventually became the Crab Nebula. And this shows us it went from a pinpoint of bright light to the current day Crab Nebula in 1,000 years. It gives us some really cool data. This old observation, this almost ancient observation, really, gives us a pinpoint for the date it started, so we can measure its expansion across a much longer span of time than we've had the astronomical tools to do so, which is really cool too. Right now, 1,000 years later, the remnant is 6 light years wide. Now, light years, again, are stupid huge. Like, a light second is something on the order of 300,000 kilometers. Several times the diameter of Earth in 1 second. A light minute is 60 times that. A light hour is 60 times that. A light day is 24 times that. A light year is 365.24 times that. That's a big fucking number. And this is 6 light years across in just 1,000 years. Those remains are hauling ass. I mean, a supernova is a big fucking explosion, so of course, they're hauling ass. But still, here's another view that shows that kind of ripple effect in the surface of the interstellar medium that we were seeing a bit of in the other image. And from this perspective, it makes it look much more like a ripple, but we can't quite rule out that whirlpool-looking thing because the distance between the ripples varies depending on where in the image you're seeing it. It is really cool, though. I mean, I wouldn't want to be within 6 light years of that explosion because all this matter that's making, the big old cloud we can observe now, highly charged particles, deadly radiation, to be within 6 light years of that star, it'd sterilize your solar system. You couldn't hide in a cave deep enough. So peering deep into M1, the spectacular Hubble image captures the nebula's beating heart, the rapidly spinning pulsar at its core. Bright wisps are moving outward from the pulsar, the rightmost of the 2 bright stars near the center of the image, at half the speed of light to form an expanding ring. These wisps form along magnetic field lines in a gas of extremely energetic particles driven into space by the highly magnetized, rapid rotating neutron star. Oh, hey, we can see the ripples doing the ripple thing. That's cool. That's so good. So this is the pulsar they're talking about, and you can see jets both above and below, creating ripples in the interstellar medium. Like you can see a distortion, a jet going below, but this is from a jet above where it goes up and then it kind of spreads out. That's so neat. And that's over the course of a couple of months. Because we're talking interstellar distances here. That's wild. So a ripple like that in space. My goodness. And all this is only possible because we have invested so much into sciences. Alas, friends, we live in an era where people are trying to take the money away from sciences for nefarious reasons involving power and deeds most devilish. So let us pause for a moment and reflect on the antithesis of this level of cool.
I have a problem with this stuff being normalized across the spectrum, and specifically, like, why push this on kids? Why introduce this to kids?
I am a depraved wretch. I am a great sinner. I'm a worm, completely undeserving of any love or any grace. I'm nothing. I'm nothing.
You're incapable of being a good person. You're an evil person. You're a terrible person. At the core fabric of who you are. That's why we need laws. We need laws because we're bad people. All of us are bad people.
You can't spell Pride Month without demon. PRIDEMONTH.
If we don't know who the women are, because they are just people, then we won't be able to pull the women up to equality with men.
We have to try to limit the harm. And that means reducing or keeping down the number of people who transition. And that's for two reasons. One of them is that every one of those people is a person who's been damaged. But the second one is every one of those people is basically, a huge problem to a sane world.
Transgenderism must be eradicated.
The LGBT, transgender, grooming our children's minds is a national security threat. We need to hold people for treason, start having some public hearings, and start executing people.
I will use whatever gives me victory. I don't care about the truth, and I don't care about the law. I care about one thing, the control.
But then they rigged the election, and now we won, so I'm going to be your president. Then what happened is they rigged the election, and I became president, so that was a good thing.
I agreed with many, many things you said during, in fact, probably more than most other candidates when you were running for president, but I still would not have voted for you because you're an Indian.
I just want to say I feel good about the Republican Party. I feel good about where we're going as a nation. We're killing all the right people and we're cutting your taxes.
It was actually a tremendous blessing to these children for them to be killed and go to heaven and be with God.
We've been hoodwinked. We've been taken in by an ideology crafted by creeps and then pushed on children.
Stop letting people pressure you into thinking.
If they die, they die.
I want to be ignorant, honestly.
Being a Christian doesn't exclude us from experiencing spiritual dryness.
We're bad people. All of us are bad people.
And of course, if you're experiencing spiritual dryness, head to epicwaterfilters.com and enter code EMBER15 at checkout for 15% off. Because, you know. All right. Now we're going to get into the progress part of the pride flag. We start with the black stripe. Now, I do want to point out, while all the stripes and inclusions in this flag have meaning, the black stripe gets very confused. People presume that the black and brown stripes stand for black and brown people, but that's not actually the case. The brown stands for all people of color, because we have the same people attacking both groups for the same reasons. It's white supremacy. That's just what it is. The black stripe, though, has a specific meaning. It is to honor the people who died in the AIDS epidemic. Because we need a reminder not only of the people who died because we're so hated by certain groups who really, really like to have power and use it to hurt people, but we need to remember that while the Democrats and other liberals may at times be effectively useless, the Republicans will fucking kill us gleefully. So that's what the black stripe is. It's a memoriam. Now, the flags version, the space flags version, is a little bit more celebration of human accomplishment type stuff. It is composed of the Hubble Deep Field, which itself was a legendary accomplishment. We can see it here. It's a stupid high resolution photo that you could zoom into 4 days and find more galaxies and whatnot. And this, of course, was later succeeded by the the Ultra Deep Field. But still, one thing at a time. I mean, you can see at this level, that's obviously a galaxy, and then that's a smaller galaxy, and then that's a smaller galaxy, and it just keeps going. They're all galaxies, with the possible exception of this might be a foreground star. But yeah, we just aimed a telescope at the most black section of space we could find with no stars in it, and we shot. And it's just like all galaxies, like Olber's paradox. Holy shit. It's just galaxies and galaxies and galaxies. Like, you keep zooming in and they keep getting smaller and smaller and dimmer. But everywhere you find a break between galaxies, there's more galaxies in there. Whole fucking galaxies. Like, not stars, not solar systems, not globular clusters, not Magellanic clouds. Galaxies. It blows the mind how vast the fucking cosmos is when you see this kind of thing. So astronomers at the Space Telescope Science Institute, the day this was written, which was March of 2004. So in March of 2004, unveiled the deepest portrait of the visible universe ever achieved by humankind, the Hubble Ultra Deep Field. The 1 million second long exposure reveals the first galaxies to emerge from the so-called Dark Ages, the time shortly after the Big Bang when the first stars reheated the cold, dark universe. Now, it wasn't that cold. The universe became dark after the last scattering, right? Like, the universe started with a hot, dense state, as you may be aware. And it was basically plasma. The whole universe was plasma. But once it expanded to a certain point, expanding stuff cools, especially gas, but whatever you got, as it expands, it cools. When it reached a certain point, another dew point, if you will, all of a sudden reionization was possible. Or deionization, whatever. Electrons could attach to protons and form stable atoms for the first time. And so photons stopped bouncing around like crazy ping pongs and were able to proceed in straight lines for the first time ever. And that is what produced the cosmic microwave background radiation. That happened when the average temperature of the universe was somewhere around 5,000 Kelvin. And since the spectrum of things, both the power spectrum and the spectrum, the colors, are determined by the heat of the emitter, that's what gives us the shape of the cosmic microwave background radiation. That's how we can tell what temperature it was, because we can reverse the effects of redshift, the stretching that's resulted from the expansion of the universe. And so we can see what it looked like at the time it was emitted. After that, there was a period of time where the universe was effectively dark, in that there weren't like major sources of photon emission in the way stars are today, right? Because it was just loose atoms. They took a while. We don't know exactly how long. It seems like our models for how long it took are off by quite a bit. It seems they can come together quite quickly, especially in a younger universe where things are much closer together. But whatever. In that period between the last scattering, which was basically a wall of light, and then darkness, except it wouldn't be darkness. because the CMBR was produced everywhere at the same time, or close enough that a person experiencing time the way we do wouldn't notice a difference. Like it'd be like turning off a light bulb. It does take a delay, but it looks pretty dang close to instant from how you perceive it. But the thing is, everywhere else in the universe is emitting that same light in the same wavelength and intensity at the same time. So the photons from the atoms near you would go past you at the speed of light, but the atoms after them would be right behind it, and the atoms after them would be right behind it, and so on and so on and so on, effectively to the edge of the universe. And so from your perspective, it wouldn't actually go dark, even though no new photons are being produced. Because wherever we look, the CMBR is still there. That light is still on. It's just been stretched to the point that it's in the microwave band. But that light is still on. It's pretty wild when you think about it. But I digress. We're looking with the Hubble Ultra Deep Field, we're looking back and back and back through time, because every light year away is also a light or a year ago, right? Because it takes light a year to travel that distance. So the more light years away we look, the further back in time we're looking. And so some of those more distant galaxies are approaching that time between the last scattering and when the first stars turned on. And that's pretty cool. So yeah, I've probably gone on a bit too long, but we're you know what? If we spend a little too much extra time on science, I'm willing to live with that, because the whole point of the show is for all of us to learn stuff. And I don't know, space is one of my favorite things, as you know. It's a dang shame that more people aren't space enthusiasts. Like, one of the things that frustrates me about the way humans generally human is there's so much emphasis on philosophy and what's the purpose of my life and what does thus and such supernatural being intend for humankind, and all of it. It's so very self-centered. And some of the questions, some of the things philosophy wonders about are valid things that are good to wonder about. Sometimes philosophy leads us to new sciences, which is really cool too. But the way so many people put this emphasis on what does it mean for me? What about, I don't want to get into a big old critique of society, like the way we put millions, hundreds of millions of dollars into professional sports ball teams where they play hand egg and slap each other on the butt and take money away from the kinds of sciences that can take us deep into the origins of the universe like this. Our priorities are seriously fucked. But it's not just a political thing, right? Like it's a social thing. People's interests seem to be geared in a way that I don't quite understand, and I'm trying to figure it out. But we can see the results in real time. Like, for example, some shows on this channel, this very program, Learn Together Live, have hundreds of viewers, whereas some shows like this one that are very science focused, well, right now we have 12.5. And don't get me wrong, I'm very glad y'all are here. I appreciate you being here and being nerdy with me about space stuff. But it shows me that there are very, very few of us in our pro-science community that actually give a fuck about science. They're much more interested in when we use science to demolish political Luddites, which can be fun, but it's less educational, I don't know. We're all doing our best in our own way. I just don't understand people, and I need to figure it out real damn quick. But for now, we have more flag to get to. So I need to shrinky me back down. Bloop. Nope, not that one. Bloop. Nope, not that one. I'll find the button. There we go. There's the button. All right. Next up, the brown stripe, which actually does represent people of color, it's a part of Jupiter. It comes from, Jupiter. I know we think of Jupiter as like red and white, like a pizza, but there's a lot of it that's brown. Brown and orange are the same color, but at different lightnesses. And whatever, it's not super important. It's from Jupiter. Let's learn about Jupiter. Jupiter's zonal winds going in opposite directions generate eddies of all sizes that manifest in storms swirling in the atmosphere. At the highest level, pop-up clouds, the small bright clouds that amass at the edge of one of these fronts, are thought to be parcels of air pushed up to the altitude at which ammonia ice condenses. It's the same phenomena we see on Earth. You pass a dew point, you start condensing. Although they appear to be small, these bright storms may be 16 to 31 miles across. Now, there once was a time when storms being more than a couple miles across here on Earth was a rarity, but now we've got storms that are stretching thousands of miles because humans don't care about science enough. This image captures Jupiter's north temperate belt, which is somewhat analogous to Earth's north temperate belt, which much of the northern United States is in. So it's kind of our home away from home after a fashion. It was taken on October 16th, 2021 at 10:11 a.m. Pacific Daylight Time at NASA's Juno spacecraft. So it was actually Juno's time. Whatever time that happens to be. Because once you're off Earth, time zone becomes kind of arbitrary. Now, there are different conventions for how to measure time in space. As a general rule, we tend to try to keep Earth clocks because that way the space mission can stay synced up with how people are operating on Earth. You don't have to. It's just a convention for convenience. But how do you do it, right? Like NASA space missions, United States space missions tend to go with Central Time because after launch, they communicate with Houston. Russian missions tend to go with, I forget the name of the time zone, but it's a Russian time zone because that's where the Baikonur Cosmodrome is located, where their mission command is. European missions, I'd have to look this one up. I want to say it's set to universal time, which would be Earth standard if humans could cooperate, which is the time in Greenwich because that's where the prime meridian is. But I'm not 100% sure. The Europeans may use some other arbitrary, I don't know. But it'd be nice if we had like a universal planetary time. It would. I digress. People do indeed come here for the tangents. Maybe that's my problem. There's not enough tangents on the science broadcasts. C'est la vie. So yeah, there's links to Juno's raw images and things. It's very, very cool. And there's a lot more to learn about Jupiter, of course. But we have other stripes to get to. So let's go to the light blue as we enter the trans colors portion of the Progress Pride flag. So light blue. This is from the sun. Specifically, there's an observatory that uses different filters to help us keep track of what the sun is up to. And coincidentally, the next layer is related to this layer, but that's neither here nor there. So the sun, this is an image of the sun emitting a strong solar flare from very recently. This is not the same image as on the flag. This is from just days ago. But it's from the Solar Dynamics Observatory, which watches the sun constantly and captured video of the event. Now, we do have a couple different observatories looking at the sun, and it's really, really cool because sometimes we'll see the ISS transit, and sometimes we'll see, Mercury transit, or all kinds of neat things. But here's our image of a solar flare shooting off. Well, maybe it won't shoot off. I don't know, but you can see it gathering. And these are different wavelength views so that we can better keep track of what's happening. You can see different things in these different wavelengths. And it's really, really, it's not just neat, but it's great for science reasons. Like in this wavelength set, You can really see the loops and whorls in the corona because the sun is not as stable as it seems. Now, also keep in mind the gravity on the sun is fucking ridiculous. 99% of the mass of the solar system is on the sun. So if you combined all the mass of all the planets together, you'd still only make up maybe 1% of the same gravitational force you'd experience on the sun. And we know that on Jupiter, we would be smooshed. We would not like it. It would not be a happy time. And Jupiter is it's much stronger than the Earth, but it's still just a tiny fraction of what's on the sun. So if you set foot on the sun, you would be smooshed flat. You would be less than a millimeter tall. I mean, you'd be a puddle, but it would be a puddle less than a millimeter tall. You could, of course, go in a protective cage, perhaps made of tungsten, which is one of the few elements that has a high enough boiling point that it won't melt immediately upon contact with the solar surface. But it also would be smooshed flat. You would also be 1 millimeter tall. You would just be inside a squished tin can that doesn't melt immediately. The gravity is very strong. So the reason I mention that is when you see these big solar flares, these big masses of matter erupting from the surface of the sun, that's the kind of gravity they're pushing against. If you've ever thrown something directly up into the air, you know how powerfully gravity pulls back on things trying to get away. And that's Earth's weak-ass gravity. On the sun, it's so much stronger. And here's this big mass that's just ejecting into space to give you some sense of the immense forces at work with these coronal mass ejections. It's fucking wild. But that's the light blue color. It's from these observatories monitoring the sun for sunspots. And I also want to, I don't know if you can see, but over here on the right side, there's this weird promontory horsehead looking thing. Those happen sometimes too. The reason both solar flares and those happen and these weird loopy doodads is because of the intense strength of the sun's magnetic field, because magnetic forces, while a much more abridged range than gravity, are much stronger up close. And I mean much stronger. So perhaps building some kind of magnetic cage would be the way to go if you want to survive setting foot on the surface of the sun. But of course, gravity is gravity regardless, and you'll still be a puddle less than 1 millimeter tall on the bottom of your cage, which magnetically maintains its integrity. So yeah, it's don't go walking on the sun. Don't listen to Smash Mouth. Do not. May as well try walking on the sun. It's not good for you. Not an environment designed for humans. But when we do get a really cool coronal mass ejection, it can produce auroras, and that leads us to our pink color. Now, this is not the same as what's on the flag, but it's very similar. You can see with auroras, there's often a whole lot of different colors. We've got the deep purple and the night, the pink, and there's a thin layer of light blue before we get to the green. Now, the different colors aren't just atmospheric layers. It also tells you which elements are being excited by the infalling radiation from the solar flare. And that's really cool too. I forget which is which. I have a chart saved somewhere, and maybe I should have pulled it up, but I didn't want to get like too in-depth on any of these specific things, so we could cover all of them today. But some of them are the oxygen layers, some of them are nitrogen, and there's a couple others too that all produce different colors depending on both the temperature and pressure of where the interaction is happening, which layer of the atmosphere, but also the density of the element there that's being activated. And it's so fucking cool. And it's because of these elemental interactions in layers of the atmosphere that not only do we get different colors, but different behaviors. Like the pink layers seem to be like gently falling, like pixie dust kind of thing. But the green layers, they tend to whip around and move like waves on an ocean. And considering how vast the sky is, it's actually much faster than that. And so it's just so cool. I realized this whole past year, hell, almost 2 years at this point, we've been having so much solar activity. There's been an aurora of some kind almost every night. Remember when they used to be rare? They're supposed to be rare, but whatever. You've had better opportunities than ever to catch one, hopefully. It still can be tricky, though. In my part of the country, it's cloudy more often than not, even in the nice weather. And so I haven't actually caught one yet myself, but other photographers who live near me have because they live in less cloudy areas. It's very fucking cool. Like, unbelievably cool. I digress, though. The pink part is from the auroras, and those are caused by the solar flares. Charged particles. It's not just photons, the same way sunlight is. It's particles. It's alpha and beta radiation and other goodies. Molecules that have a charge, ions, all sorts of things. So, yeah. Oh, yes, when you see the aurora from space, that's a really cool effect too, because the way it interacts with certain layers of the atmosphere creates this effect where it looks like there's a dome over the Earth. It really can, because it looks like the particles are hitting a dome. It's so neat. I used to have an image in my OBS to that effect. Oh, goodness. I am very, very dry today. It's I blame my heater. I mean, it's a fantastic heater, but when you have your heater running all the time because it's so very cold, it dries the air right the hell out. So pardon me for a moment. I'm gonna find us another quick ad. Let's see here. If you need something to drink out of, we have a thing for that too. Hey, want to do something good? Recently, a person who had sent me this version of my logo, unsolicited, made public statements promoting violence against minority women and survivors of abuse. Now that person's gift will do some good instead. 100% of the proceeds from sales of this survivor's mug will go to fund the nonprofit organization RAIN in their efforts to provide vital resources to survivors and to build a future where fewer of us need this kind of help. Find this item at my store at betterthanember.com. And if you want to learn more about how you can be better at supporting survivors, check out this video, where I've distilled the best practices for helping survivors that I collected from speaking with actual crisis professionals at RAIN, Willow Grove, Vera House, and independent counselors. Whenever you can turn the harmful acts of others into something good, that is an epic win. Okay. Oh, goodness. I'm trying. Oh, I'm trying to catch up with the stuff, and I'm just never gonna. But I appreciate y'all being here today. I'm trying to finish the pride flag before we end the show, so at least the whole thing is done. And I really need to pick up the pace. I'm doing a bad job at this. I'm not. I don't think. I mean, yes, I'm taking a lot of breaks, but I'm very dry. So okay, continuing on. Who's the next thing? The next thing we just did the pink. So next is the white. The white, which for some reason I'm not seeing. Okay, there it is. Right. Okay. The white is these. Yes, we're back on Earth. This is the sky above Antarctica. Well, almost Antarctica. Indian Ocean. Here's a little island kind of thing. The one from the flag is actually on Earth looking up, but we get these weird vortices in this area near Antarctica semi-regularly. They have a name. They're von Karman vortices. So I'll once again show the Space Pride flag so that y'all can see why this is a remarkable thing. It's remarkable enough of an atmospheric phenomenon that it made it into the flag, right? It's It's pretty cool. So let's learn about these. What are these? On a clear day, Heard Island stands as a small drum-shaped patch of rock and snow amidst a vast expanse of blue. Located in the southwestern Indian Ocean. Oh, I should do the tour guide thing again. Located in the southwestern Indian Ocean and only accessible by boat, the small volcanic island is situated 4,000 kilometers southwest of Western Australia, 4,700 kilometers southeast of Africa, and 1,000 kilometers north of Antarctica. When the operational land imager on Landsat 8, we said Landsat 9 for the other one, Landsat 8 captured this image of Heard Island. Just the tip of Mawson Peak, the highest point on the island, was visible through the sheet of marine stratocumulus clouds swirling over this part of the furious 50s, the latitude. Though just 2,745 meters tall, the mountain was tall enough to stir up several cloud vortices that swirled downwind like eddies in a fast-moving river. So, TLDR, there's this volcano. This isn't the only one, but it's one of the more obvious ones that pokes right into this layer of the atmosphere where these clouds often form. And you can see it's coming right off of the mountain. It's the pride flag is taken from the mountain looking upward at the vortices, but they do happen a lot. But this is why the wind goes past the mountain and it creates these void spaces that then swirl off and continue swirling as they wander off in the prevailing winds. And it's pretty neat. It's just a quirky effect of some of the weirdness we have going on Earth, because Earth has some nifty shit going on. Now, the bonus parts, the extra bits, the yellow, the other yellow. I realize there's already a yellow, there's already a purple, but I used a different yellow and a different purple so I could put more space onto the flag, because the point is for science as well as solidarity. It's fabulousness. So the yellow I used was the central part of Spiral Galaxy NGC 4622. Not only because it was the shade of yellow that I needed, but also because it's a weirdo. It spins backwards. Now, what do we mean by spins backwards? Because we see galaxies in every possible orientation. We see them on side, we see them on the other side, we see them this way, that way, the other way. Having a galaxy that's looking at us head on, but spinning in the other direction than, say, Andromeda is not unusual. About half of them do. What we mean by spinning backwards is that our spectral analysis of the movement of the stars shows that instead of the spokes of its spirals being trailing behind the rotation, they're leading the rotation. It's almost like it's spinning normally like a pinwheel, but time is running backwards in that galaxy. But if that were the case, that would have serious impacts on its spectrum too, which, would make the things that should be red shifted look blue shifted and vice versa, making it look like the galaxy is spinning backwards. Oh, wait, that's exactly what we see, isn't it? But never mind that for now. Our current best hypothesis is that something massive passed by the galaxy and disturbed the entire thing all at once, such that its effective orbital rotation around its own center of mass is completely reversed, but without disturbing the gas and dust patterns that give rise to the spiral arms that we see. Somehow. Although, in fairness, as far-fetched as that hypothesis sounds, it is probably more reasonable than to suggest that time is running backwards in that galaxy. It sounds ludicrous when you put it that way, until you start running tests. But never mind. I'm being facetious. It's a hypothesis, but I don't have any grounds or any mechanism for that. It's just a fun thing to say. But it is rotating backwards from what we can tell, based on the redshift, blue shift data of the stars. the spokes are leading the rotation. It's turning into its spokes, and we don't know why. We just have speculation at this point. We can't find anything that could be responsible for that one way or the other. It's very fascinating because it's a curiosity we don't understand yet, and we'd like to, because it's weird. And that's what often leads science, the weird things we don't actually understand. And that's why it made the perfect yellow part for the intersex inclusion in the flag, because there's something interesting happening, even if people don't really understand what or why. It's still a real thing that deserves fucking respect. And then that leads us to, of course, the purple section in the very middle, which obviously this whole image is not purple. I took a section where it's very purpley for the flag, which I will put on screen again for comparison. We only see a tiny little bit, but it is this purpley section, which is oh, it's so cool. It's so cool. So this is NGC 3603. Now, like many other things, we image it in a whole bunch of different ways. This is visible light. This is near infrared, the H2 region, a whole bunch of stuff. The version that I have, I believe, is from James Webb. I'm not 100% sure because I haven't been able to find it after I originally found it. Like, it's complicated. In any case, it is this nebula, though. It was observed by John Herschel in 1834 during his visit to South Africa. Now, that's remarkable for a couple of different reasons. We knew from sailors that the southern hemisphere had an entirely different arrangement of stars and constellations and other cool stuff, such as the Magellanic Clouds, not normally visible from the northern hemisphere. So astronomers knew there was cool stuff to look at, but they had no idea how much cool stuff there was to look at. And this, along with a whole bunch of other nebulae, is what convinced northern astronomers that they needed to properly study the south. It wasn't just different stars. There were unique phenomena going on down here that needed to be looked at, or down there, depending on your point of view. And which is why there is a European Southern Observatory today, is in part because of the impact Herschel's and later scientists' studies did in the South. There's another book. I know I reference a lot of books, but books are fucking cool, from the early 20th century, called When Worlds Collide. I originally intended to use the When Worlds Collide video that we did a few days ago as like a launching point to start talking about some of the ideas in that book. But the show did so terribly that I can't do a follow-up, because if I can't reference a show that nobody watched, you know, I can't draw on that for information because nobody knows what I'm talking about, which is unfortunate. But in that book, astronomers in the north need photos from South Africa to analyze, to plot the course of an approaching rogue planet from outside the solar system. Is it going to pass Earth? Is it going to hit Earth? What's going to happen? We need to know. We need that data. But it could only be observed from the southern hemisphere. And it's a really neat part of the story. I digress, though. People come here for the tangents. I know, which is why we have a shirt about it. Yes, this side. Shirts. We have merch, betterthanember.com. Tap on the store link and you can find all kinds of cool stuff, including that shirt, you know, if you want. Okay, John Herschel in 1834, who remarked that it was a very remarkable object, hence his remarking on it, perhaps a globular cluster. Herschel cataloged it as Nebula 3334 in his Results of Astronomical Observations made at the Cape of Good Hope, published in 1847. In 1864, the Royal Society published his General Catalog of Nebulae and Clusters, where he listed it as number 2354. It was subsequently incorporated into the new General Catalog, NGC, as J.L.E. Dreyer, by J.L.E. Dreyer, as NGC 3603. So the numbers things get varies from catalog to catalog, which is why when you hear people refer to astronomical stuff, they'll often give it an abbreviation like M for the Messier catalog or NGC for the New General Catalog. It's so you know which book they're getting that number from, so you can look up what the hell they're talking about. It's a somewhat disorganized mechanism of citations, but it's pretty neat because then you get a whole bunch of different catalogs to look through and compare information. The central cluster was cataloged as the star HD 9795. Hey, there's the image I was looking for. It's from the central. Okay, found it. Found it, guys. The central core of the superstar cluster within the NGC 3603 H2 region. That's hydrogen 2, referring to the emission lines found in and absorption lines. Emission and absorption lines are the same thing, depending on whether the energy is coming or going. And hydrogen 2 is a line that lets you know there's a high intensity of hydrogen in the area. It's, it's pretty cool. It's very, very cool. There's, of course, more about this and all the other things, but oh my God, it's so pretty. I love the star so much, folks. I always have. And I appreciate y'all being here to share this exploration of the pride flag with me, because in the words of the immortal Markiplier, oh, that's so cool. All right. And we've made it to time. We've completed our mission on time, no less. Now, I'd happily go over on this kind of thing. And there's a lot more to talk about. There's so much more in space, both locally and far in the distance. It's just a damn shame that there's only a few of us who have any interest at all. But I'm glad those of you who are here. It means a lot to me for a whole bunch of reasons. In any case, in happier news, we did some cool stuff today, and we're going to do some cool stuff tonight. I had been low-key planning to aim for my 2nd anniversary as the next time I did a big milestone event, but 100 weeks has a really nice ring to it. So I hope you'll join tonight for that. My general plan is I'm going to look for some of the more frequently asked questions for trans people and try to answer them, possibly on Reddit, possibly on Quora, but I'm also going to take questions from the live chat, as long as they're good faith. Like, assholes and trolls obviously aren't getting any love from me. If you're interested in that kind of thing, do join. It potentially could be a lot of fun. In whether you do or not, though, we're, as always, here every weekday at 11 a.m. Eastern. If you're new here and you've made it this far, first of all, you're a boss, because not a lot of people did. Second, subscribe, join us. We'd love to see you in the future. And yeah, the secret to surviving 700 days is to survive one day and then do it again and keep doing it. It's one of those times when that's what we all have to do, I think. Thank you all so much for being here. And as always, remember, you don't have to defund science in order to keep people ignorant and hyper-focused on the bread and circuses and killing each other so they don't notice how badly they're being screwed by the upper 1%, because you are better than religion. We'll see you later. Thanks to all our patrons and top-level members for December. Miranda, Karen Butcher, Jessica the Transmetal Alchemist, Robin Webster, Maya Adkison, Jimmy Tux, Ian Chen, Lilith, Ember Lynn, The Barely Bearable Atheist, Eric Wander, Jason Jacoby, Lil of All Trades, Deviant Outcast, Kelly King, the Detroit Atheist Queen, The Mighty Filbert, Secular Feelinist, and Geo Sam. And you can add your name here next month by signing up at patreon.com/betterthanember, or by joining Emberships here on YouTube at the Cinder level, which includes all the custom emojis, tons of member-exclusive content, member-only live streams, and a bunch of other stuff. I deeply appreciate all the supporters who keep this channel going. Thank you so much. Because of you, we're building a wonderful community that I'm very proud of.
Just like a spark that's breaking out, can't make a stop, can't turn back now. We know that there's no room for doubt.